Hi everyone, let's get started. So today in this class we will be talking about Python classes and inheritance. If you remember last time we talked about creating our own data types by using classes. We looked at two examples. We created a coordinate object and did some operations with it. We also looked at creating a fraction class and doing some mathematical operations. So today we will be talking a little bit more about classes. We will talk about some special getter and setter methods, how information hiding works in terms of data variables or data attributes for classes, and how classes handle them internally. We will also touch upon the concept of class variables as opposed to instance variables. And lastly, we will talk about inheritance within classes, the parent-child relationships between classes. So there's a difference between implementing a class and using a class. And we write code from two different perspectives, keeping both of these things in mind. Implementing a class would mean that we are defining the class, we are defining the data attributes, which means what is the object composed of in terms of data elements or variables. And then we define the methods or procedures within the class, which define how we or other programmers can use this object. Um, in terms of using the class, when we use a class in code, we create an instance of that object, and then we can do operations on them using the methods or procedures that we defined as the interface of that class. The class definition has many different aspects or parts in it. The class name that we define as the definition of a class it becomes a new data type within our program, and we can create any number of objects, any number of instances of that data type. We use the keyword self in the definition of our procedures or methods of the class, which is an abstract way of pointing back to any arbitrary instance that we might be using in the definition or creation of the instance of that class type. For example, within our procedures, we can say self.x minus self.y. What this would mean in real life is that when an object is created of that data type, this C1 and C2 would become self in this context when that procedure within the class is called or invoked. And then we define the data, which means what is the class composed of, and the methods, which defines what this class can do. These data and method attributes of the class are common across all instances of the class that we define. So this is instance number one, this is instance number two. Both of these would be able to access the data and methods as defined as a definition of this class. Um, so one instance, for example, here we are creating a coordinate with the x value of 1 and y value of 2. Um, so this is one instance of this class type, this data type or class called coordinate, and we can access its data members. We can access its methods as part of the implementation of a problem that we are solving or an algorithm that we are writing. Um, so each instance carry with itself the whole structure of the class, which includes all of the data types and all of the methods. Let's talk about how this relates to real life. So here, let's see, we have a few different objects in front of us, few different items or things. And some of them are of the same type, while others make probably another group. So if you look at them a little bit carefully, they all have some attributes. They could do some things. Let's say this cat has a name, it has an age, and it has a color. And similarly, other instances or other objects of similar type would also have similar or same properties: a name, an age, and a color. And same here: name, age, and color. When we talk about a slightly different object, it would have an age and a color, probably not a name, and then age and color for this rabbit as well, and an age and color for this rabbit as well. So what we do when writing programs is we try to identify groups or sets of objects that have similar data attributes and behavioral or method attributes as part of their definition. So here we can see clearly that all the cats have three attributes: a name, an age, and a color, while all rabbits have two attributes: an age and a color. So we can group them in two different independent groups. We will call this the class cat, and we will call this a class rabbit. So grouping them is, as we saw in the previous lecture as well, we group items as part of the definition of one class or one data type that have similar data attributes and similar procedural attributes. The data attributes define what the class is or what the object is, and procedural attributes, on the other hand, define what it can do or how we can interact with it. And so that way we can group items together as part of one definition, and that becomes in our code that is represented as a class. So let's say we create a class called animal. So we have a class definition. The name of the class is animal, and it is inherited from the data type object. And we have an initialization function in it, a method called init, which will create an instance and set some necessary values which are passed to it as its instance variable. So we are saying here that age is a number that whenever we create a class, whenever we create an instance of the class animal, we will pass it an age, which will be set to the class instance variable of age. So self.age is equal to age. We also have a instance variable or data attribute called name. We are not passing it in the initialization function, in the init function, but we are just setting it to none. We could modify our definition of this init method and pass it the name as well. But as far as any animal is concerned, not all of them have names. So let's just default it to none. So when we create an instance of animal, we will call it my animal, and we will pass it an age. This will for the init function, this 3 would be passed into this variable age, and then this age variable will be set as the self.age value for this instance, my animal, of the class animal. So that was a very simple example of creating an instance of this class. Second item that we will talk about today is adding some more functionality or some more behavior to this class. And these are the getter and setter methods, some very basic parts of the definition of a class that we have. So these getter methods return a specific data attribute. So we define a function called get age. There are no parameters received by it, but as we talked before, self is always the first parameter for all the class methods. And all it's doing is returning the self.age value. Similarly, we have get name method that returns the value of the name variable of that instance. Then we have some setter methods. These methods receive a value and set it in the corresponding instance variable. So it gets a new age, um, and as part of this set age method, and sets it as the value of self.age. And similarly, when we want to set the name of an animal instance, we will pass it this value, which will be set as the instance variable names value. Lastly, we have a print str function here that would simply print that it's an animal with this name and this age. We will take a look at a few examples in a few minutes. So when we are working from outside the class in our code, we should always use the getter methods to get the values and setter methods to set the values. We should not be directly accessing these instance variables. And the reason for that is that the implementation or the name of these variables as part of the implementation of the class might change, but as long as this interface does not change, we can still use them. So there are two ways. We created an instance of animal. We called it A, and we passed it the age 3. Now there are two ways of accessing this age of this animal. We can simply say a.age, but we can also use, which is the preferable method, to use the get age function of this class. Um, and the reason for that is that the internal implementation as part of enhancement to the implementation of this class animal might change. For example, inside the class, we might start calling this years instead of age, but as long as get age function name does not change, we can still ask for the age of this animal. So if we change our internal variable name from age to years, all creation of this instance would not change. We are still passing it a number as age, which is being set as the age of this instance variable. When we want to get the age, we are still calling get age function, which did not change. But internally, it is returning the value of the variable years instead of the variable age. So that way, the users of this class or other programmers do not need to change their code, even if the internal implementation of a class has been updated, as far as the interface that we have defined to interact with it has not changed. So although we prefer to use methods to access the data of an instance, Python does not restrict you from that. So we can always, as a programmer, always call a.age. We can also set it to a value which is not a number, and we can add new data attributes to the instance by just assigning a.size to be something. And Python does not restrict you from doing this. In other programming languages, for example, C, C++, you can define instance variables or the definition of data attributes within a class to be public, private, and protected. That would stop programmers from directly accessing them based on their visibility. And that's why using getter and setter methods for accessing the data within the class is preferable. And it is not a good idea to use the instance variables directly by their name, because their internal implementation might change. There is another concept of having default arguments. For example, this is the set name function, set name method for this animal class, and we are saying that It has the first parameter is always self, which would point back to that instance name. And then we are saying it's getting a new name, and the new name has a default value of being an empty string. And then whatever value is received here, we are assigning it to the name of the object. So let's say you just call set name without any parameter. This default value will be used, and the name will be set to an empty string. But if you give it a value, then that value will be used as the parameter value. So here, if we say A is an animal of age 3, and then we call the set name function, its name will be set to empty string. Okay. But if we say A is an animal of age 3 and we set the name to Fluffy, then this value will be saved as part of the name as name of this animal instance. So let's talk about hierarchies within objects. So we have a few items that we see here. All of them are, let's call them either mammals or animal. They're all living beings, so they can be categorized or classified as animals. But within all of these animals, there are further subgroups. So there are some cats, there are some rabbits, and there are some people. And even within people, there are two types. There are grown-ups, and then there are some students. So all of these different, and all of them may have slightly different behavior. There are some data attributes and some behavior which is common to all animals. And then cats might have a slightly different implementation of speaking. For example, it would make a sound. Rabbits might not speak at all. And when people speak, they speak in English while cat makes a sound. So those kind of implementations may differ, but there are some common attributes. And the hierarchy that it follows is that all persons, cats and rabbits are animals, and all students are persons. Okay, but you cannot say that a person is equal to a cat or something. So that way we define the hierarchies within our class definitions. This is a parent class for these three, and then person is a parent class for student. Okay. And whenever we create a new layer or the next level of hierarchy, we can add more information in terms of its data attributes and its behavior. And we can also, if a behavior is defined in person, for example, and we want to change it for student, same behavior can be changed, and that concept is known as overriding. We will take a look at an example for that as well. So let's say this is the animal object that we talked about. It has an initialization function, and it has two getters, getting the age and the name. It has two setters, setting the age and the name. And here you can see the same example that the setter method of name has a default value of empty string. So that if you call it without any parameter, this empty string would be defaulted to the name instance variable. And then we have the str function, which would simply print that this is an animal of this name and this age. Let's implement another method here. Let's say we are now creating a class cat, which has a parent class of animal, and we are adding a new function, a new behavior in it, call it speak, and all it does is makes a sound or prints meow. And we are updating or overriding the print function str. We had the str function as part of the implementation of animal, but we are redefining str function as part of the cat class, and we are changing it a little bit. Instead of calling it animal with this name and age, we are going to print that this is a cat with this name and this age. So we can add new functionality here, and we can change some functionality here. Both of these things are very commonly used in defining classes. Let's take a look at the code for this. So we have this animal object. Let's run this. So the object is defined, and we are doing a few tests. Okay. Um, let's run this again. So um, at first we are creating an animal with the age 4, and then we are printing that animal. So animal, no name, and age 4 is printed. If we print the get age for this a instance, that would be the value 4, which was given to it as initialization. And then we are going to set the name for this animal to Fluffy and print it again. So this time, as you saw previously, it printed animal with no name, age 4. This time it printed it as animal with the name Fluffy and age 4. And if we call set name once again without any value, it would use the default parameter over here and set the value of name of this instance back to empty string. And if we print it once again, we would get no value in the where there should be a name. Um, yeah, let's go back to the slide. So that was a little bit of example of using this instance. So which um, subclasses can have methods with the same name as the superclass. So in this example, for example, animal is printing an init method, but a cat might also implement an init method. And what we want to do here is either just write it completely independently, or there are a few different types of behaviors here. If you call a method for an instance and that method is not defined in the class definition, what Python will do is take a look at its parent. If it is defined over there, it would call the parent's method with the same name. And if it is not present in any of its hierarchy all the way up to object, then you as a programmer would get an error. But at the same time, if there is an implementation in the current class, the Python interpreter will use that definition in the current instance. But you can also use all of the previous functionality or all of the functionality of the parent definition for a method and then add something to it. For example, here we are now creating a class person, which is also inherited from the superclass animal. And in the initialization or the init method, what we are doing is we are calling the animals init method with the age parameter. Since in animals init method, we only set or we were expecting the age parameter. However, for the person's init method, we are getting a name and an age. So we will use the value of age to call the init method of the parent. And once that's done, then we are setting the name as well as part of the new functionality or additional functionality for the init of person. And we are creating a new data element called friends, and we are giving it the value of an empty list, which means this person, an instance of this person can have any number of friends. Now, since we already had, as part of the implementation of animal, we already had the getter and setter for name and age. We don't have to redefine them here unless we want to modify them or add some new feature in it. But we are defining a new getter method for friends, and all it does is simply returns the list of friends back to the programmer. We are also adding a new function to add a friend, and it gets a friend name. If that friend name is not present, not already present in self.friends, then it adds it using the append function. And we are modifying the function speak. We already had that. We did not have that in the definition of animal, but we did implement speak in the implementation of cat. That was a slightly different one. But for a person, when a person instance would speak, he would print hello instead of cats printing meow. And there is a new functionality for this person that we can pass it another person here, and compare it with the self age, and the difference would be returned back to as a return value, or it would be printed. Nothing is being returned as part of this definition, but it would print what's the age difference between any two persons, self and other. And lastly, we have a print function here, the str function, and it's all different than the animal str function. Here we are saying that this is a person with this name and this age. We have a few examples here. Let's take a look at that. So before we move on, here's the a few examples for the usage of cat class. We did not create the instance A. Let's comment that line out. So for cat, what we are doing is creating an instance C and setting its name as Fluffy and then printing it. So this is the result of that. There is a cat named Fluffy with the age 5. And when we ask it to speak, it says meow. And then when we print the get age method, we get the age back. So that was a simple usage of the cat class that we had created. Let's comment this back out, and let's talk about persons. So we have a person class. The definition is here. We have the init method, which uses the animal init, and in addition, it sets a name, sets an empty friends list. It can get friends, it can speak, it can add a new friend if it's not already in the list. It can calculate the age difference between two person objects, and it can print that this is a person with this name and this age. So if we run this part of code, we defined a person Jack with the age 30. We defined a person Jill with the age 25. And if we ask any of them to speak, they would say hello. And the age difference between them, which is a result of this line number 80 here, that would be 5-year difference. So 30 minus 25 is 5. That's how we might be using this class. Okay. Now we are creating another class here. We are creating a class called student, and the parent of this student is person. Now student would have, since the parent is person, student would inherit all of the data attributes and all of the behavior of the person, and it might add or change some part of it. So when we create a student, we send it a name and an age and a major, since it's studying. It's a student. And as part of its initialization, we first call its parents init method, and its parents init method was expecting a name and an age. So we pass it, and that is set as part of the execution of this init. In addition to that, we are now saying that, okay, since it's a student, it has another variable, instance variable called major. So let's set it to whatever we received from here. And major here would have a default value of none. If we don't pass it, this would be set as none. Then we have a method to change the major. If we receive a new major, it would be set back into the major value of the major instance variable here. And we are changing the speak functionality quite a bit. So this is now overriding the function speak of the person. And all it's doing is it's adding 4 options instead of just one hello. So if a person speaks, it would also always say hello. But when a student speaks, what we are doing is generating a random number between 0 and 1. And if 25% of the time it would say I have homework, 25% of the time it would say I need sleep, and then a quarter of a time it would say I should eat, and if none of those, then it would say I'm watching TV. So when we run this, every time it would be a different output. It might be same depending on what the random value is generated, but we are overriding the functionality of speaking for the student, which is a subclass of person, and that's different than how a person would have spoken. And lastly, we are overriding the print function, and here we are saying that this is a student with this name, this age, and this major. So if we look at that example, now we have a student. This is the definition that I had just shown you on the slide. And what we are doing here is that we would create two students, Alice and Beth. One of them has a major of computer science, and the other one does not have a major. And then we will see both of them speaking a bit. So when we run this code, we have a student Alice with computer science major age 20. We have a student Beth with age 18, no major. And Alice is saying, I need sleep. Beth is saying, I'm watching TV. If I run exactly the same code again, since we are using this random function here to create a random number and then assigning or deciding what to speak, if I run this again, what they say might be exactly same and it might be a little bit different. Let's run it once again. Now both are watching TV. Now one is saying I should eat, the other has homework, and one is still watching TV, the other one still has homework. So based on the number generated by this random number, we are changing or deciding what the person is doing at this time, or and then they talk about it. Um, let's move on. Okay, now here's another concept of using class variables. So far, all we have talked about are instance variables. Those instance variables are private or are part of one specific instance, but there are instances where we might want to have a class variable that is common to all instances of that class. And we will use this rabbit example for that. So let's say we have a rabbit class defined, which is inherited from the animal superclass. And we have a new class variable here called tag. And we will use it to tag different instances of rabbits. In the init method, what we are doing here is first we are calling the parent class init method so that it can set the age. And then we are setting the parents of this rabbit. Initially, we are not passing it any parents, and we would use this functionality or this value of parents later on. And then we are setting rabbit ID as RID for this instance. And for setting the rabbit ID, what we are doing is accessing the class variable of tag and assigning the current value of tag to the rabbit ID. And then we would update the tag and increment it by 1. So all of the future usages of tag for any other instance of rabbit class, the tag value would have changed to 2. So let's say we created a rabbit here, and when the first rabbit is created, its rabbit ID will be 1 because the class variable tag was 1. And then we created another rabbit, and this was the second rabbit. Now, when we updated this one here, we updated the tag value in the class to 2. So this second rabbit would get the tag of 2, and it would update the class value to 2 plus 1, which becomes 3. Now this tag would be unique to the rabbit ID that we give to any rabbit which we have newly created would be unique because we are using this tag class variable, which is common across all instances and increasing it every time. And that's one way of using class variables and accessing it through different instances of the same class. Here's the implementation of the overall rabbit class. We are defining a class rabbit inherited from the class animal. We have a class variable here tag. Then we have the init method, which first calls the init of the animal. sets the two instance variables of parent1, parent2, and then sets the rabbit ID based on the class variable tag, and then increments the tag for future instances of the rabbit class to use the updated value. We can get the rabbit ID. We can get the parent one and get the parent two. These would be some methods that we have defined on this. Zfill is a built-in function of string data type, and all it does is it formats the printout a little bit nicely. So if the value is 1, it would, since we called zfill 3, it would be 3 characters long, and all of the leading values before this number would be 0. So that all rabbit IDs show up a little bit nicely and consistently. Okay. Now let's implement. So this was the basic definition, and nothing special going on here. Let's say we want to breed rabbits. Okay. And for that purpose, we will implement the add operator for rabbits. And the way we would call it is that if we say R4 is equal to R1 plus R2, now R4 would be a new instance of rabbit. Of course, it would get whatever the ID tag was available at that time. But at the same time, its parents will be set as R1 and R2. Okay. Um, so here, when we say the implementation of add is that we are returning a new rabbit with 0 age, and parent one would be self, and parent two would be other. Okay. Now, parent one would point to self would point to this first argument, parent one, and other would point to the second argument, parent two, as we had in the definition of this init over here. So for over here, we are assuming that R1 and R2 are instances of rabbits, and we are creating a new one with these two as parents. And as part of this function, it would create a new instance of rabbit with two parents, which are used as the parameter here. Let's take an example before we go forward. Okay. So rabbit tests. We said R1 is a rabbit. It got the ID, RID of 1. R2 was number 2. R3 was the third rabbit, got the ID number 3. And if we want to check the parents of R1, since as part of the init, we just set them as none. The default value was used. That's why the parents of R1 are, there are no parents since we did not define any. If we use that add operation that we just defined over here, you can see that add is returning a new rabbit with 0 age and self as one parameter and other as the other parent. So we are saying that R4 is R1 plus R2. Now R4 would be a new rabbit instance with R1 and R2 as its parents. If we run this part of code, testing rabbit addition, we said R1 is rabbit 1, R2 is rabbit 2, and R4 is rabbit 4. And if you want to see who are the parents of R4, since we created it using this add operator, the parents of R4 would be rabbit 1 and 2. Here, rabbit 1 from here and rabbit 2 from here. So that's how we would be using this add operator that we had just implemented by creating a new rabbit and setting its parent as these two arguments. Going back to the code, next we want to check, let's say we want to check if two rabbits are equal to each other. And the way we would define that is that both of its parents are same, then the rabbit is same. It's not a very absolute or nice way of checking, but let's say that's how we want to implement it. Okay. And the implementation would be that the way we define them, we can define parent one and two arbitrarily. Like we can say R3 is parent one, R4 is parent two. But we can also say that R4 is parent one and R3 is parent two. So we have to check both ways. We can say both parents are same, that parent one of self and parent one of other are same, and parent two of self and parent two of other are same, but they can also be opposite. For example, parent one of self is equal to parent two of other, or parent two of self is equal to parent one of other. If any of these conditions are true, that their same parents in one and two are same, or their opposite parents in one and two are same, then return the result of this logical operation, that either their same parents at same position are exactly same, or the parents at the opposite positions are exactly same, by using this OR operator. If any of these is true, then these two rabbits are equal. Okay. Uh, let's take a look at that part of our code. So we are saying that we are creating two new rabbits. R5 has parents R3 and R4. So R3 would become parent one, R4 would become parent two. And there is another rabbit called R6, where R4 is parent one and R3 is parent two. The order doesn't matter because that's how we have implemented our equality operator. And then we are going to print the parents and checking whether they have same parents or not by using this equality operator here. So when we run this part of code, we have R3, R4, and then 5 and 6 we created. The parents of R5 are 3, and second parent is 4. For R6, parent is 4 and 3, 1 and 2. So if we check whether R5 and 6 have same parents, the result is true as part of this return statement, as part of the value of printing the value of this equality operator. And if we check parents of R4 and R6 are same, they are not. So the return value of this equality check would be false here. So that's how we can enhance the implementation of our classes. We can use the implementation from parent classes in their children, enhance them. We can also override it completely with a completely new definition. And if the implementation of a function is not present in a child definition, then Python would always check in its parent. If it's present, it would run it. If it's not present, it would keep on checking in the hierarchy all the way up to the object data type. If that function or method is defined, it would call it. We also talked about default values or default parameters for functions. And we also talked about some class variables and using them across all instances of an object. So overall, object-oriented programming is creating our own data types, our own collections of data, and that way we can organize information into classes that make sense to be together, and defining classes differently, dividing up behavior between parent and children. That would make sense for our implementation. It's a very good use of that. Since we create a class once and then use it many times in our programs, it's a consistent way of using a set of functionality, and we encapsulate all of that in a class definition. And the way we have updated, for example, speak function, an animal in general does not speak. A cat may speak differently than person, and then a student may speak a little bit differently than person, um, as its child. So we have added layers of complexity between as we go along in our hierarchy of parent-child relationship of classes. And just as we broke down functionality into functions, instead of writing just one long program doing everything for us, First, we talked about how to create functions to divide up functionality in pieces that can be run independently. Classes are another mechanism for decomposition and abstraction, and we can encapsulate a certain set of data elements and behavior into a class and then define its instance and use it in our implementation. All right. So that would be the end of this class. Thank you, everyone. Next time we would start a completely new topic. Thank you. Bye.